Hello and welcome. This video is part of a series exploring statistical techniques and methods in kinesiology. Specifically, we will be exploring the paired t-test. To begin, let's cover the basic setup for this analysis. Our data are pre- and post-test assessments of bench press power in units of watts at 45% of one repetition maximum. Assessments correspond to results for a single group of 11 participants before and after 8 weeks of a high-load cluster bench press training program. The data for this example are synthetic in nature. That means these data do not come from actual participants, but were instead created artificially. However, these synthetic data were generated using summary estimates from the study by Davies et al. Cited here. In this case, our research question asks whether mean bench press power significantly differs between pre-test and post-test following 8 weeks of high-load cluster bench press training in resistance-trained adults. Within a null hypothesis significance testing framework, our null hypothesis is that mean bench press power does not significantly differ between pre-test and post-test following 8 weeks of high-load cluster bench press training in resistance-trained adults. Our alternative hypothesis is that mean bench press power does significantly differ between pre-test and post-test following 8 weeks of high-load cluster bench press training in resistance-trained adults. Before beginning the analysis, let's briefly review the assumptions associated with this test. 1. The sample data we analyze should be continuous in nature. 2. Each pair of observations within the sample should be independent of every other pair of observations. 3. Our sample should be drawn randomly from the underlying population. And 4. The differences between paired observations should be approximately normal or normally distributed. Let's now perform our example paired t-test in R. To begin with our paired t-test analysis using R running within RStudio, we need to read in the data. In this case, I have entered the data as vectors within a data frame directly into the editor. We will first create a variable named diffs, representing the paired differences of the observations for later use in examining the normality assumption. We can then create mean and standard deviation summaries for both the pre-test and post-test. We can then examine the t.test function by placing a question mark in front of it within the editor. When that line is passed to the console, you will see function documentation appear in the help pane at the lower right. This documentation details the function's call, arguments, and returned values. Of note, t.test is the primary base function used for performing t-tests in R. Next, we can perform the t-test by passing the pre- and post-test data as vectors within the data frame dat into the t-test function. We need to tell R explicitly that we are conducting a paired t-test in this case by including the paired equals true, or t, argument. When this line is run, results from the paired t-test are printed to the console, including the observed t-statistic, degrees of freedom, and associated p-value. Additionally, the mean difference and 95% confidence interval are displayed by default. We could subsequently evaluate normality, first by plotting a histogram of the paired differences and superimposing a normal curve for reference. We could take this a step further by constructing a QQ plot for graphically assessing normality. Lastly, we could do a formal test for normality by passing the paired differences to the Shapiro-Wilk test, with the results printed to the console. Let's now perform our example paired t-test in JASP. To begin our paired t-test analysis in JASP, we need to read in the data by navigating to the 3 horizontal bars in the upper left-hand corner and selecting the Open option. From there, we can navigate to the data and read them in. In this case, I recently opened these data in JASP, so I will select it directly via the Recent Files option. After the data are read in, we will then navigate to the top menu bar and select t-tests. We then will scroll down and under Classical, select the Paired Samples t-test option. Once the Paired Samples t-test analysis menu appears at the left, you will select the variables and move them into the variable pairs box at the right. JASP will automatically run the paired t-test at this point. We could then choose to select the location parameter to display the mean paired difference, and we could also generate the 95% confidence interval for this paired difference by selecting the 95% confidence box below the location parameter. We could also check the descriptives box to display the sample size, means, and standard deviations. Subsequently, under assumption checks, we could check the normality box to display results from the Shapiro-Wilk test. We could also check the QQ plot residuals box to display a QQ plot of the paired differences for graphically assessing normality. Let's now interpret the output of our statistical analysis. As a reminder, the question we are asking in this specific example is whether mean bench press power significantly differs between the pre-test and post-test in resistance-trained adults. In this case, our sample means differ by over 42 watts. Examining our output from JASP and R, we see that our observed t-statistic is approximately negative 2.59, and when we evaluate that at n-1 degrees of freedom, which is 10 degrees of freedom in this case, we observe a p-value of 0.027. Since our observed p-value is less than 0.05, we conclude that these results are significant. Before formalizing our interpretation of these results in the context of our hypothesis, let's check our assumptions. In this example, we accepted from the outset that we were working with continuous data, that the pairs of observations were independent of each other, and that our data were obtained using random sampling. The last assumption we need to check is whether the differences between paired observations are approximately normal or normally distributed. Examining the QQ plot, we want to see whether or not the observations line up along the red diagonal. In general, the data here are lining up quite nicely along that diagonal, suggesting that the data are likely normally distributed. Lastly, we can use a formal statistical test such as the Shapiro-Wilk test to evaluate normality further. The observed p-value here of 0.63 from the Shapiro-Wilk test is quite large, and because that p-value is greater than 0.05, the results from this test suggest that there is a lack of evidence these data are non-normal. As such, we can conclude these data are sufficiently normal to meet the normality assumption associated with this test. Moving on to the final evaluation of our hypothesis, because we observed a significant p-value for the paired t-test less than 0.05, we reject the null hypothesis. We would then state that there is sufficient evidence to conclude that mean bench press power significantly differs between the pre-test and post-test following 8 weeks of high-load cluster bench press training in resistance-trained adults. That concludes this video describing the paired t-test with examples in R and JASP.